There we go. No, that was the one that was due by midnight. Okay, good. That was the one that was from Tuesday. And then I had to take my hat back because we were fasting. So I just sort of like let that be Tuesday and Wednesday. But that one was due. I don't know. If I have enough time when I get through this, I'll go and I'll look. It's so slow right now. I don't want to run out of time. Okay, for today, I mentioned this yesterday. Where is the, more often than not, the original source for streams and rivers and creeks and your channeled, huh? No, not most of the origins of them. Their source, their headwaters. Yes, overflow will put water in a stream, but they're normally already established, and then the overflow gets diverted into the channel. No, that's normally where they end up.
Areas of high elevation.
There we go, up in the mountains. I mean, not all streams start with snowmelt, okay, but a vast majority of them do. Yes, you were right when you said the overflow of water. That's true, but normally that then it might channel itself into, as a tributary, into a larger stream or a river. So hopefully we'll get through this rather quick. I will show you how to calculate the velocity of a stream or a river, but I don't ask you to actually do it on the assignment itself. So you said overland flow. That's actually one of the first things that's on here. Water will always go to the lowest point. That's what it does. So you go from higher elevation to, yes, to lower elevation. I'll open up the notes. Okay. Check it. I probably did something wrong. I did this a couple weeks ago and then I just had absolute chaos. We are on stream gradient notes. Edit. I probably didn't change the date right. You go to click on it and it doesn't do anything? Okay. Let me go into my stuff and I'll reload it. Give me just a second. We are in the 6 weeks. Stream gradient notes right there. Share. Gosh, everything's slow. Copy link. Let me reload it. Okay, try refreshing it and reopening it and see if it goes through. Because I recopied it. I probably when I change it off of edit to copy, sometimes I hit the wrong thing. Did it go? Yeah, okay. So I forgot where I was at. Okay, so like I said in the opener, not all streams are going to start up like in the mountain peaks, but a large majority of them have at least one tributary that does. I'm talking about a river system then. What makes them go from higher to lower elevation is just the force of gravity. Now your rivers aren't necessarily going to go in a straight line. Okay, they'll go around the weaknesses. They don't go around the weaknesses, they actually go through the weaknesses of bedrock because it's easier to move. Water will do the shortest path possible. And it wants to go down. And eventually, what it really wants to do is go back to sea level. Overland flow would be the precipitation that stays surface and does not go round. Okay, so that's what you think of as rivers and streams and lakes and seas, the stuff that you can physically see. Now, eventually, and this is where you were close, that excess water on the surface will be channeled into a stream of some type. Natural springs. So a couple different ways. That's what's called, I just got coffee on my glasses. It's called a karst system. And I didn't go that far into it. when you have precipitation that goes underground in a cave system, eventually some of them actually find their way back out. That's what you think of an actual spring. Normally is safe to drink right out of the spring. I'm telling you just to go stick your face in every pond that you see and drink it because you're probably going to get like really, really, really sick. But normally natural spring water is okay. What's almost always okay to drink straight from the source is if you go up into the mountains and it's being fed by a glacier. Because that's about as pure as the water's going to get. Yep. Now, if you're drinking anything out of a river, there's going to be fish pee and poo and other things like that in there. But the closer to a source you are, the better the chance that you're not going to get sick if you drink it. If you end up doing like back camping and stuff, they make these little, almost looks like a straw, and you can drink directly out of rivers and lakes with it because it's got internal filters that takes something like that. Yeah. I've got a couple different ways to filter water actually, just because I've had to deal with hurricanes and you don't have water for extended periods of time or electricity and there's flood water everywhere. So you don't want to drink flood water. This is the formula to calculate the flow of the river. How much water is it pumping out? Depending on if you're in our country, which we normally measure in feet, to be cubic feet per second, okay? Or if your metric system, it would be cubic meters per second. It's how much volume of water passes a given point in a second. Okay, so because rivers are three-dimensional, you've got width, okay, you've got depth, okay, but then you've also got the velocity, which is what the V stands for, whether they be in meters or feet, because that's just depends on who's putting their stuff together. So it's essentially the area of your a cross section, if you will, like from shore to shore. What is the area if you could just cut it, like make the Red Sea happen and you can walk through it? That times the actual speed of the river, which velocity and speed are the same damn thing. One's just going, like which direction is it flowing? I can't remember if I put another one on here or not, and I lost my sheet paper. No, I did this one here. Oh, I put the picture right here. And I yanked off the internet. So like I said, you basically go from shore to shore, you do a cross section, that's your area, that's your width and your depth, whether it be meters or feet, and then you need to multiply that by the speed. I am not going to specifically ask you to do that on the assignment, but I could, like on a test, because I haven't a major test yet. We'll see how next week goes, because Monday's asynchronous, Tuesday I have to take my cat to the specialist. If I have to put him to sleep, I don't know if I can be here Wednesday or not. We'll have to figure that out. I'm not the most sensitive of people, but it's different when you have to put a pet down. This is a hydrograph, a graph of the amount of water. So you see a couple different things on this. The blue spikes, okay, that's precipitation. And then it sort of waits a little bit. And then that red line is the change in the elevation of the surface of your river. And so it takes some time from when the rain actually falls for everything to be channeled to the river to increase its height. It's not instantaneous. And there's different things that can affect what's called lag time. How much time does it take for the river to figure out that it's going to have more coming down? And this is what causes flash flooding too, especially if the riverbed went dry. So this is the rain. I'm not going to make you like do any math off of this. And then this is eventually the river starts ticking up and it's going to stay higher even though the rain has stopped because it's channeling itself, whether it be surface or ground, it's channeling itself towards that point where the I don't even know what the name of the instrument is that measures this. I didn't look that up. I know the graph is a hydrograph. Wherever the instrument is that measures the volume of the water that's going through the river. The further away it is from the precipitation that occurred, the larger the lag time. It also is affected by how much urbanization has happened around the river. The more concrete jungle, the more problems you're going to have. So the rains, How much time does it take to get from where it rains to your stream, to whatever your channelized flowing water is? If it has not been urbanized, you're going to have the highest rate of precipitation and percolation down into the water table. If it has been urbanized, which means that we have built roads, houses, parking lots, stuff that the water can't seep through, that's where you're going to see a greater change in the lag time between the actual event and the rise of the river. Now, there are, I don't know what it's called. I know what it looks like. It's almost like asphalt, like blacktop road asphalt, but it's really porous. So when it rains, instead of just like, staying in the gutter and going down the drain system, it actually goes through into the ground underneath it. And I can't remember, it wasn't that long ago, I saw it. I don't know where they're putting those road surface substitutes. I don't know what that stuff is called. But that kind of a surface probably does not last as long as blacktop or asphalt, concrete, whatever you want to call it. But as far as allowing the percolation to occur, it's better. I have to look that up and add that into this. It's been a few years. If it percolates, okay, so it becomes an underground aquifer or it hits the water table, it goes down into karst systems, caves. Sometimes, and you had mentioned what's a natural spring, it makes its way back out as surface. They interchange back and forth with each other. You're going to have in a good system something called base flow. And base flow really is not affected by precipitation. Precipitation can be sporadic, more rain, higher river. But it doesn't always rain, and the rivers don't necessarily always dry out because they have base flow from groundwater, which is constantly giving a steady supply of water to whatever the stream, river, creek, brook, whatever you want to call it. This is critical to the environments for fish and things like crayfish, all the other little crustaceans and critters. Even down to the things that you can't see with the naked eye. Things like euglenias, parameciums, and amoebas. You don't want to get an amoeba. Those things are bad. They'll kill you. So with this graph, which is similar to a it is a hydrograph, but it's a baseline. So the light blue, that is your base flow, and it stays fairly consistent. And yes, as we have precipitation, you see small spikes with the base flow, but it's not. As long as you have enough of a groundwater tap, if you will, your stream is not going to run dry. Which class? I know you do ecosystems and biology. I bet you do some in aquatics and definitely environmental. I guess we sort of talked about it when we did the different stages of evolution, but I didn't really go too far into an entire ecosystem. Things like food chains and food webs. I know you do that in biology. I got two different things going on the right-hand side. The top one, image A, is showing that where the water table is, that you're actually having water supporting the stream. Okay, this would be like base flow. It's not necessarily raining, it's just that the water table compared to where the stream is the water table above the normal height of the stream or is it below it? If it's below it, then the stream is going to be supplying its water. It's going to percolate down towards the water table, which is the bottom one on B. And I know it's sort of hard to see the arrowheads on this, but on the top one, on the water tables above it, it's going to go from high concentration to low concentration. So this is supplying water to the stream, where this one, the stream is supplying water back to the water table. If it's gaining water from the water table, it's a gaining stream. And if it's giving its water to the water table, it is a losing stream. Does not mean it's necessarily going to dry out. Over time, it would. If you don't have any other kind of precipitation or other tributaries that are supplying that part of the system. Because I was going to see some people. Oh, you guys can't see over my head. Let me see. Nope, but I did now. But yes, I'm definitely going to be sort of winging next week on when we are doing things. I'm still right now hoping to be able to do the test on this water unit Friday in a week. It just depends. Depends on what I find out on Tuesday. I don't know. I just don't know. We sort of mentioned this yesterday. Yes, the water's going to be moving downhill, higher elevation to lower elevation. The smaller one that gives its water to the larger system, that is the tributary. Okay, the larger stream that's being fed, that is part of your river system. You can have tons of tributaries that feed into a major river system. In fact, the more tributaries you have, the stronger your river is going to be. The better chance you're not going to have a dry out of the system. Yes, some weird things do happen where rivers, sometimes they change their course and where they were before dries out, but it's not that the river died, it just moved where it was. Do you know where I got this picture from? Because it's not Earth. That is an ancient riverbed. You don't know the only other planet that's got liquid water on its surface is Mars. I don't know exactly where on Mars. Okay, but we know Mars does have liquid water. It has ice. It's just its atmosphere is nowhere near as wonderful as ours is. And so when there is water that's available, it tries to boil out into the atmosphere. It has to do with the heat of vaporization, essentially, on Mars. So you have all these different tributaries. We've got the nice little crater over there. And then this right here would have been your major river system. There's another one right here. And then that would be its major. I bet you they would have joined up down here, but I don't have a more blown out image of that. But yeah, Mars used to be a lot more Earth-like. Something weird happens. But it does still have surface water from time to time. Very, very, very small amount, very salty, very seasonal. I just heard that, I'm assuming it's NASA. I didn't hear that part of the thing on the news this morning, but they have this mask now that will take an hour to generate, I think it's 20 minutes of breathable oxygen just from the atmosphere of Mars, which I know sounds like it takes an hour just to get 20 minutes. That sucks, but it's a step in the right direction because it's most likely y'all's generation that'll go in about another 10 years. But they're I don't know if it was NASA, I don't know if it was SpaceX. I know we just launched some more astronauts up into space this morning, or they're about to. It didn't happen already. Normally watch that stuff. So this was basically your opener. So your higher elevation up towards the peak. Those are oftentimes called a source, or they are called headwaters. They are where the water system is starting from. Yes, a lot of times this has to do with melting snow and ice, or glaciers for that matter. The bottom part, where it's hitting the ocean, that sort of fanned out thing, that thing's called a delta. That is the mouth of the river. So the beginning of a river, its origin is a source. The ending of the river, when it empties into a larger body of water like the ocean or a sea, that is the mouth. You have smaller streams joining a larger stream, those would all be tributaries. So your main source is this one. That's definitely a tributary, and so is that one. I know, I just point, I have arrows pointing to what's what. Now, there's a couple things that we did mention yesterday, but I did not go into depth. What happens when streams and rivers mature? Because they do some weird things. A young stream flows fast, cuts deep. A mature stream slows slower and cuts wide. It has to do with their elevation change, which is what this is about, gradients. How steep is the slope? So source or headwaters, higher elevation, they cut narrow, steep river channels. Okay, it doesn't mean it's always going to look like something like the Grand Canyon, okay, but because they're traveling faster, you have more erosion and those cut deeper. Yes, it does also matter the consistency of the bedrock. Some things are more impervious to erosion than others. When it becomes mature, when you get closer to the mouth or the end of the river, you have less of a change in elevation. Your river slows down. I'm not saying it's not moving water, it's just how steep the slope is the main thing that controls its velocity. Slows down, so you don't have as much erosion deep, but you do towards the banks. And your mature ones are the ones that like to do something called meandering. And that's what that back and forth snake-like looking thing is. That's a meander. You've got the inside and the outside of a stream in this case. Your faster ones, the ones that people like to go whitewater rafting on, those don't do that as much. The fastest part of a straighter river is smack dab in the center. The fastest part of a meandering river like this is on the outside bank. Just for your information, if you ever do go whitewater rafting, there's certain places where you're supposed to keep the raft. Every now and then, this would be a good spot for it. You have a change in the course of the river, and it would cut off this loop, and it would create something called an oxbow, which is like a lake. I think that's on the next one. Let's see. I mentioned this in just in passing, and then also a couple slides ago. Your elevation drop is called a gradient. If you've ever driven in the mountains, it puts the grade of the road for like the big 18-wheelers, because some of them can't make them up too steep of a grade or slope. It is normally done for us. How many feet does it drop in every mile of distance? Like if you could just draw a straight line. In the metric, it would be how many meters does it drop per kilometer? It's still the same concept. How much does it go down over a certain distance over? That drop is a gradient. The steeper it is, the higher the gradient, the faster the speed. Or velocity. Like I said, the only difference between speed and velocity, they're both meters per second. We use the metric one because that's the physics, but velocity will be a direction. So is the river flowing south? That's what changes it from speed, which would just be, I don't know, let's say 30 cubic feet per second. But when you start telling it direction, it gives it what's called a vector. For those of you that have had physics, you've heard of that word. I know you have. Like I said, towards the mouth, you have less of a drop per distance of length. Lower gradient slows the velocity. It also reduces the erosion. You still have erosion. You still have deposition. You have it in both, but you have more erosion and less deposition here. You've got less No, yes, less erosion, and you've got more deposition here, more depositing of things like silt, rocks, which we call a load for streams, and there's 3 different types. What does it carry? And it depends on what it's eroding as to what it does carry. There's so many pictures on this. That one didn't have an image. All right, this is what's called the Great Divide, or the Continental Divide. To the left of that red line, and it goes all the way up into Canada. This is the Rockies and the Cascades and the Sierra Nevadas and all those, one big giant chain down into South America, even down along like where Chile is. But if you ever go and visit, is it Yellowstone or was it Teton? Maybe it was on the way to Teton from Yellowstone. There's a lake that sits right on the Continental Divide, and it actually has 2 different streams. One of them ends up going into the Atlantic Ocean, and the other one ends up going into the Pacific Ocean. And to my knowledge, it is the only lake that actually feeds both oceans, because it's sitting right smack dab on the middle of the Continental Divide. It's the ridge, like the top ridge of the Rocky Mountains. Most lakes, most rivers only go into one ocean. What? When it curves back and forth, it's called a meander. Just like when people meander and they just sort of walk around and don't really have any idea where the heck they're going. It's the same thing. If you have a straight channeled body of water, okay, it's not going back and forth like what you said, the curvy one. It's not meandering. It's pretty much straight. The fastest speed will be pretty much smack dab in the center of your river, because that's probably the deepest part of the river. And it's having to push more water per spot, more feet per second, or more meters per second if it's metric, same thing. So straight channels, like I said, channels just the umbrella term for a flowing body of water. Oh, that's the wrong color. I'll have to fix that. Oh well. Straight channels are the fastest in the middle. If it is a meandering river that's going back and forth, the fastest river is on the outside bend, and the slowest part of the river is on the inside bend. The outside bend erodes because it's faster, and the inside of the bend deposits because it's slower. And if you do decide to build a house somewhere on the side of a decent channelized body of water, you need to pay attention to which side of the river you're building on, because otherwise your house is going to fall into the water. So just for your information, you build on the inside bend and hope that the river does not change course. So erosion is on the outer bank, and deposition is on the inner bank. You build on the inside, not on the outside. But like I said, things can happen, especially with meandering rivers, and they can change course. You're not going to put the river back where it came from. You're going to have to figure out where to move your stuff. Did I put point bars on the next one? Okay, I'm missing something. No, I must have put it on the next slide because I talk about point bars in it. This, when I printed this out, I altered my notes. Let me fix that color. It's gonna bother me. That lighter blue is right next to the darker blue. Okay. I'm going to go too fast. I'm trying to. So the meandering are the S-curve ones. These are the mature rivers. Yeah, I did put point bars here. Point bars are sort of like sandbars. If you've ever been to the ocean, they build up on that inside curve. We already just mentioned that erosion's on the outside. If it jumps its bank and it changes its course, a lot of times one of those S loops, like this one, gets cut off. And that is called an oxbow lake. The river has changed its course. This river originally had this as part of it. You can see, right there, you can see a little bit. But for whatever reason, this river changed its course. It may have been an insane waterfall that happened, precipitation, and it just couldn't stay within the banks of its channel. Another good area that this would happen would either be right here or right here. That would be easier for it because it's less land it has to chew through. I mean, I guess if you really wanted to, and you had the right equipment and the time to do it, you could do that to a river on purpose. Okay, so upper elevation, high gradient, high change in elevation over distance. Like I said, these streams cut deep. They don't always do Grand Canyon stuff, but because they're moving faster, they have more erosion along the bottom, normally in the center of said channel, and it cuts a deeper canyon. Does not have to be in the mountains, but it's going to happen more commonly there. And it's also what happens when we have uplifting. We haven't done tectonics in a little while. That is what happened with the Grand Canyon. You had uplifting of that whole section. That's why there's all those plateaus and stuff over there. But that river didn't care, and it kept cutting through it. I have not been to the Grand Canyon, but that is one of the things that is on my list that I have to see before I die. I was supposed to one year, and then the economy went, and we went, nope. Cancel all of our vacations. Base level, ultimate base level is the ocean. That's as low as your stream is going to cut. That's it. You cannot cut anymore. Now there could be bedrock that it can't get through. I said it could just be emptying into either, maybe it could be a watershed, not a watershed, I apologize, a water table if it's not at sea level. It could be a lake, the ocean. The ultimate endpoint of all rivers is supposed to be the ocean. The ocean is called the Great Basin. One more on here. They don't have to be the base level for a river. You can have temporary ones. Lakes, seas. And yesterday we mentioned that the only difference between a lake and a sea is how much salt content there is. If it's not salty, it's a lake. If it has a higher salt content at all, it is a sea. They're still landlocked. We'll get through this with plenty of time. Oh, pollen is so bad. Hopefully the rain today will wash some of it out. And plant to stop making more than sand. Okay, I thought I had a little more in there. I don't. I probably could have cut this slide out because this just says the same thing as 2 slides ago, basically. As you go towards the mouth and the gradient is less steep, because we're closer to base level, it doesn't cut as deep, but that's more because of the velocity that's happening. I basically said this the exact same thing in a much less scientific way, like 2 slides ago. When you do have less of a cut, you still have erosion, okay, but it's not at the bottom, it's towards the sides, and specifically on the outer bank with these. But that is the exact same thing that I said a couple slides ago. It's just more of the language of what I'm supposed to be using and not simplifying it. Lateral just means to the sides, the inside and the outside bank. We're going to talk about the three major loads of a stream, and then the difference between alluvial fans and deltas. Let's go. There are three loads in a stream. If it's completely dissolved in the water and you can't see it, like salt, that's a dissolved load. If it settles out more towards the mouth, it's going to be a suspended load. This is going to be your smaller particles that aren't completely dissolved, but get carried with the water. Like these are your finer particles. And then you have the bed load, which are the bigger things like rocks, chunks of gold, and garnets and stuff like that, that the larger particles fall out first. And as you go further down the stream, smaller and smaller and smaller particles, I'm speaking today again, that's what I get without sleeping for 4 days. Smaller ones are going to settle out the closer you get to the mouth, so that all that's left is that very fine silt and sometimes clays. Normally towards your delta, like right where they empty into a lake, your silt's really, really, really dark and rich. Very, very fine. Oh gosh. Alluvium. Alluvium is the stuff that's deposited. It's like the scientific term for silt in rocks, no matter the size. This is the fancy term for it. An alluvial fan looks just like a delta, but an alluvial fan happens where it's more dry, more arid, where your stream empties where there's not a bunch of moisture on a valley floor. A delta looks exactly like the same thing, but it's not in an arid environment. It's emptying into a lake or an ocean. They look exactly the same. They look like, if this is your stream, you're gonna do something like this. And then you have your body of water over here. They look exactly the same. If it's an alluvial fan, it's in an arid environment. If it's a delta, it's just like the Mississippi Delta. Normal precipitation, not the deserts. I do not think I put another picture on here, but let me double check. Yeah. So I put the first two grades in the parent portal, the one on the water cycle and the one on surface and groundwater. The one on bodies of water is open through let me stop the recording. Through the weekend. Like I said, Monday is, let me stop this recording. I don't need to put that on YouTube.